Alright, in this video, we're going to be talking about the linear layout, and I'll also be pointing out how Android Studio's presentation of our project differs from what's actually on our hard drive, which we spent the last couple videos talking about. So I'm going to go ahead and I'm going to launch Android Studio, but you'll notice a big issue with when I launch Android Studio that I don't actually particularly like, and that is by default, whenever you launch it, it's going to open up your last project. I'm really not a big fan of this behavior. So what I want to do is I want to go ahead and change that so that it'll ask me, it'll bring up a new project dialog box, and it'll also allow me to change recent or open recent projects. So let's go here up to the file menu, and I'm going to jump down to settings. And what I'm going to do here is the option that we want is going to be under the general, which wherever it is. I don't even know where the general, oh, there it is. It'll be under the general IDE settings, but a quick tip when working with any IntelliJ-based platform or IDE, you'll want to go ahead and generally, if you don't know where a particular menu item may be or setting may be, go up here to the search bar on the top left. And I know this has to do with startup, so I'm just going to type in start. And what's going to happen is it'll filter all of the pages out based off that keyword search. So now you could go through each one of these, but I know it's going to be in general. When I click on general, you'll notice that it's going to highlight that particular menu option for me, which is reopen last project on startup. So I'm going to uncheck that, hit OK, close IntelliJ, and when I close it, it's always going to ask me if I'm really sure I want to exit. It's same behavior with Eclipse. I just really don't get it why that no, I click the close button. I want to close it. So I'm going to check don't ask me again on that. So let's hit exit, and then I'm going to launch Android Studio again, but this time we're going to be presented with a choose your project dialog, or create a new one if you want to. So in this case, what I'm going to do up here is I'm going to say start a new Android Studio project. And for application name, what was the thing I did before? Android Quick Start. Let's call this application name Views Part 1. And the company domain for this, now this is kind of confusing when we type in the company domain, because it wants us to type in the normal domain, despite the name. The package name is going to be the reverse domain. So don't make the mistake here of typing in something like com.buzz.stuff, because what you'll get down here in the reverse domain name is stuff.buzz.com, which isn't what we want. Instead, go ahead and type in your the actual company domain. So in this case, what I'm going to do is I'm going to say buzz.com, and now you see that the package name becomes ComBuzz Viewport 1. So now what I'm going to do, now that I have that done, I'm going to look at the project location, and I am happy with that location. Call it Views Parts 1, and then I'll hit Next. As far as the minimum SDK, I'm going to go ahead and leave it on Jelly Bean, because that's what we're going to be using, 82%. And let's go ahead and hit Next. And so we'll get this dialog. What I want to go ahead and do is I want to say add no activity. I don't want the blank activity. I'm really not a big fan of the blank activity fragment, because it really isn't a blank activity. It's an activity, it's a layout, and it's a menu, and a bunch of other stuff, and it's just, I don't know. Just kind of irritates me. And besides, we're going to be creating all our activities from scratch in this series. It's not that hard to do, and it really drives home how activities are wired into the platform. I recommend writing your activities from scratch just regardless, and I'll show you some really cool handy shortcuts that you can use in Android Studio to make writing the activity that you want much faster. But anyway, I'll say add no activity, then I'll hit finish, and it'll do its generation magic. So you'll notice that the project build scripts in Android Studio projects are slightly different than what you would get by typing in Android create project. You'll notice that what we have here is the application broken up into modules, and we have one module in our application. I'll show you what I mean by that in a sec here once this loads up. You see down here it says Gradle running tasks and indexing. Just don't bother the IDE while it's doing that. Now that it seems that it's done, I'm going to go ahead and open up my project view. And in my project view, you'll notice we have app and Gradle scripts as two little, I'll call these virtual folders. I do believe app does correspond to a location on the file system, and I can show you guys that by doing that. It does. Oh, so does Gradle. So they aren't, well, never mind, wrong Gradle. So the Gradle scripts really aren't a real folder, but app is. And that brings us back to talking about modules. So an Android application can be made up of multiple modules. A lot of times you'll probably only have one, but if you wanted to include a class library, create a class library, you could do that and you would have another module. Or if you want to have a different app or like a wearable app or something like that, then you could also use modules to do that. So over here, we have our Gradle scripts and also a bunch of other stuff. Now we have our build.gradle. Our build.gradle is going to be the kind of top level Gradle file. It contains things like our dependency on the Android build tools, for example, and also go away. And it also includes our repositories and all that fun stuff. So this is something that you're not going to have to mess with much, especially if you only have one module in your app. The more interesting build Gradle is also called build.gradle, and you'll see in parentheses right here it says module app. This is the Gradle file that's responsible for compiling and launching, or compiling and installing and testing our application. So you'll notice it has a bunch of these values set. It looks a little bit different than what we had before with our Android Create project. You'll notice down here in dependencies that it says, ignore that, but let's look at this first. It says compile, and then in quotes we have a com.android.support apt compact blah blah blah. That should look relatively familiar to you guys, because if we hop on over into our actual project, our total project Gradle file, the thing that you can think of this as our solution that we do our building from. You'll notice something similar here. We have this dependency on this class path of com android tools build Gradle blah. We see the same syntax right here. So you should start be thinking to yourself, well, it looks like this is something, a dependency, that it's going to search for in order to satisfy. And it's probably gonna look on the file system maybe, or it might look into an online repository, and you'd be right. So basically what we're doing here is we're saying we want this package, or this group rather, this package out of that group at this particular version, and we want it downloaded from the internet, presumably, assuming that you don't have this downloaded already or local anywhere, and we want to add it as a dependency to our project. So think of this as NuGet. And so the syntax that we're looking at, this is going to be the Maven sort of, I'm not sure what the actual name of this particular syntax is for referencing an app, but you'll see this very commonly with other. So all this does is it grabs a dependency online and compiles it into our app. You'll notice here there's another compile that says compile file tree dir libs include jar. Basically this instruction just says any jar that we find in the lib folder or library folder of our will be included into our project, like you would expect in a Java application. So again, not surprisingly, this dependencies folder, or this dependencies block, is just specifying the dependencies that our project has on different libraries that are available to us, both on our file system as well as on Maven Central. Then we have a bunch of other stuff. We have our Android thing, our Android block. It says compile target SDK version. We're doing 21. The version of our build tools, we're using that. We have things like our default config, which gives us our application ID, which is the name of our application, minimum SDK version, target SDK version, version code, version name. Something you would generally see in the app manifest, but in the case of the Gradle build system, these settings are primarily set from Gradle itself, because it gives us a lot more flexibility in order to change these configuration values on a per flavor or per release basis without having to worry about messing with the Android manifest file itself. Then we have our build types and our release and our minify enabled in our ProGuard file. So the same thing that we saw in the last video, or the last couple videos. Okay, then we have ProGuard rules. We really haven't really talked about ProGuard. ProGuard is just think of it as an obfuscator for Java or for Android applications. in this case. So basically what it does is it obfuscates your code, makes it more compact by changing all your class names to single letters and all your variable names to single letters and that sort of stuff. And it also makes it more secure because your code is more difficult to decompile and understand. And so this ProGuard rules.pro file is not surprisingly the rules that ProGuard will follow when doing a compilation. You'll notice it has an exception here. It says if you're using a Java web or JavaScript, or if you're using a JavaScript bridge in your web view, then uncomment that line. That's something we'll talk about later. Then we have Gradle properties, which doesn't really matter. It's just ways to change the way Gradle runs. We're not going to be using any of this for any purpose because the defaults work for us just fine. We have our settings.gradle file, which the primary purpose of this is to tell Gradle about the sub-projects, because technically this app build.gradle is a sub-project of this build.gradle. And then finally we have our local properties, which we talked about before. You don't need to worry about editing this because your changes are going to get overridden anyway. So there's no point of worrying about that. So let's go ahead and close all on that, and let's hop back into our app. So we have our manifest folder, which contains our Android manifest. We'll be coming back here soon because we'll be needing to create an activity. We have our Java folder. And now the Java folder, if you're not a Java developer, this will look a little weird. But the way typically you have Java applications structured, where you have multiple packages, you'll generally have it'll look kind of like a file explorer, but it'll collapse the paths like what you see right here. Now some of it will be hierarchical, some of it won't. What do I mean by that? Well, if I had two sub packages underneath COMBuzz viewport 1, we would see two subfolders in it. But because there's nothing above COMBuzz views part 1, then it is all collapsed. So you're actually looking at three folders right here, because as you saw in the last video, that's three folders. There's a folder for Java, there's a folder for COM, there's a folder for Buzz, and viewport 1. That's 4 folders, but I know how to count. And then you'll also see our Android test. So a couple interesting things to note. Things are kind of flipped on their head. Because you saw before how on the actual file system, in fact I can show you this, on the actual file system we have we have source, the source folder of our app, and then we have Android test and main. And they both have their own Java folders. But it's kind of flipped on the head when we look at the project view. Instead, we have one Java folder being presented to us, and then what would have been underneath two separate Java folders combined into that single Java folder. So that's how flavors are going to work also. Once we start working with flavors, you'll notice they get kind of mushed into the same thing. And that's also why I really wanted to talk about the physical structure on the hard drive before we took a close look at Android Studio, because the Android Studio representation really has nothing to do with how things are laid out on the hard drive. So if we open up, that's Java, so all of our Java code is going to go in this package right here. Now if we open up res, another interesting note, again, the same sort of thing. This res folder is a combination of all the res folders of all the flavors that we have configured in our app. So we have our drawable folder, our mitmap folder, which is similar to the drawable folder, except basically what happens here with the mitmap folder is when you decide to create or generate an APK for a different screen resolution, everything in the mitmap folder will be included. It's kind of a complicated thing to put into words. Basically, in some instances, a developer may want to create multiple versions of the same or multiple builds of the same project depending on a criteria, such as a localization or a screen density, and then have a bunch of these different APKs created. And what you would do there in that case is you would take any resources that can't be loaded for that particular build and you would remove them from the APK, thus saving space. So generally what would happen is you would build it, let's say you build an APK or build your project for a screen width of 600 or higher. Any resource that wouldn't normally ever be displayed in that screen width will be discarded. but bitmaps won't. And they use it in order to be able to create, or just the way that it presents icons on the operating system needs to have more information or be able to translate between higher and lower densities for whatever purpose that particular launcher may have. In reality, there's really not a big difference between bitmap and drawable. They both accomplish the same thing. You'll notice in the last video what we had was, or what we were using was the drawable folder from the default template from Android, but in this case it's using the bitmap folder to place its IC launcher in. Anyway, enough about that. What's interesting here, again, is how Android goes about laying out our files inside of the project window. You'll notice that we have a single res folder again. We have bitmap, and then we see iclauncher.png, but it appears as a folder. Again, that's because Android Studio is just turning this directory structure around on its head. So, in reality, these 4 files are in 4 separate folders. They're in 4 separate bitmap folders. But it's flipping it on its head. We're getting one bitmap folder, and then we're getting the 4 files grouped under a folder named the file that's under the folder. That's probably a sentence that's never been said before. Anyway, so basically what's going on here is we're being able to see a much nicer view of our project than if we just had to work with File Explorer. So we see in parentheses the qualifiers for each one of these assets, each one of these drawables. And you'll notice that they get bigger or smaller depending on if we're in high or low density. Anyway, so that's the bitmap. Then we have our values folder. Our values folder, we have strings and styles. So strings, we saw this before. We have the app name, and then in this case it's called views part 1. Then we have styles. Now what's a style? We'll talk about styles later. The point here, though, is we have a style named app theme, which is going to be the default style of our application, and that it extends from app compat, or compat. And we'll talk about app compat later. Anyway, that's it, really. There's not a whole lot else about this project. If I were to try to launch it, I'm actually curious. I've never tried to launch an empty project that doesn't have any activities in it. Let's go ahead and do that anyway, because I have to launch my... still haven't launched my emulator, or my virtual Android device. So let's make sure to get that started up. And so we'll be able to talk about views and all that fun stuff. I guess I can pause the video for a second. Alright, and we have a virtual device. Let's go ahead and hit the run button, or we can come up here and run and hit run, or we can hit shift and F10. So let's run the app. It wants me to edit the configuration, could care less. There's a whole lot of stuff that I don't need to worry about. It asks us which package we want to use. We'll use the default APK. Which activity to start, we'll launch the default activity. Which device, will show me a device chooser. And what's the before make, do a Gradle where I make. So let's hit run, and configuration is still incorrect. Do you want to edit it again? That could be because I don't have a main activity. But anyway, I'm just doing this for science right now. I'm curious. Because this should also give me the same error if somebody forgot to... also, when it asks me which device, I'm going to say use the same device for future launches, so we don't have to deal with that again. Oh wow, it even it compiles and it installs, and I don't see anything on the actual device. So that's what happens when you try to have no activity, or you don't have your activity properly configured. So let's fix that. Let's go ahead and make an activity. Up here in the app and Java, so I'll go ahead and close these out because we don't need them. App Java, buzz viewport 1. I'm going to right click, select new, and I'm going to say Java class. And I'm going to call this main activity, which is commonly what I'll use for the main activity. I will go ahead and nuke these little what's the point of putting those comments in there? If you should be using source control, right? If you're using source control, you know who made the class and on what date. So we'll go ahead and delete that little notice. I need to find out where that is in settings, because that's really annoying. Anyway, so we're going to make an activity. We're going to make it from scratch. So I'm going to show you guys every single component that we need in order to make an activity work. Now, the first thing an activity needs to do is we need to extend it from the base activity class. But it'll be a little bit surprising of what we have to actually type in here. It's not going to be the base activity class, which we have access to under android.app. It's going to be action bar activity, which comes from the Android support v7 app. So go ahead and type in action bar activity with the proper casing and then hit enter so we get the proper import. Now, we'll talk about the app compact library soon, but this is a feature of the app compact library. If you use the app compact theme, you're going to have to extend from the action bar activity provided to us by the support library. What's a support library? What's an app compact? What's an action bar? We'll talk about that later, but the point is, right now we have an activity, and action bar activity does inherit, of course, from activity as well. So you'll see that it inherits from fragment activity, and fragment activity inherits from activity. So the point that I'm trying to make is that your activity must inherit from, well, activity, from Android app activity at some point. So we could leave this the way it is, because technically activities don't have to do anything, but that's not very interesting. So what we're going to do instead is we're going to override its creation logic. So when the activity is created, when it appears or is supposed to appear on the screen, we want to tell it to use a particular layout XML file in order to present its user interface. So what I'm going to do here is I'm going to say @override. Then I'm going to say protected void on create bundle saved state. Then I'm going to say super.onCreate saved state. Interesting note, when I did bundle, Android OS bundle got imported. Okay, so what's going on here? We are overriding the onCreate method. The onCreate method is called, like I said before, when the activity class is created, when the activity itself is created, sorry. Now, the first thing we always want to do on the onCreate method is call into the super onCreate method. We'll actually get an error from Android itself if we fail to call through to the parent super onCreate. So if you ever get that error, just remember that you forgot somewhere to call through to the base class and go ahead and correct that. It's another interesting syntax difference between C# and Java. Actually, there's a couple here that's worth noting. First of all, we have this override thingy right here. What is that? Well, this is what's in Java is called an annotation. You can kind of think of it as an attribute in C# if you're familiar with that language. Basically, an annotation does nothing more than to describe additional bits of metadata about a type or about a method. So in this case, what we're doing is we're specifying the override annotation. Now, the override annotation really irritates me, personally, because it's not required. See, if I don't have the override annotation, I won't get a compiler error, and everything will just work. Like, literally, there's no functional difference between me having the override annotation and me not having the override annotation. So why do I have it here? Well, I want to make it explicit that I am overriding a method on the base class. I'm overriding the parent's onCreate method with new code. When I add the override annotation, it's not required, but if I add it, it makes it impossible for me to write a method that doesn't override something. So for example, let's do some random method which doesn't exist on the base class. So this is not an override because this name doesn't exist on the base class. Notice how I now get a compiler error. It says method does not override method from its superclass. So that's what's going on here. All this is doing is providing a little bit of a sanity check, making our code a little cleaner. It's unfortunate that the override annotation is not required for overriding members, because if you're familiar with C#, the equivalent would have been here, protected override void on create, whereas in Java it's simply protected void on create. Another quick note about Java that's different than a lot of languages, in fact any language or most languages that I'm familiar with anyway, is that all methods in Java are virtual by default, meaning every single method you write can be overridden in its children class, with the exception of methods that are marked final. So if I said protected final void right here, what that would mean is that means that child classes cannot override that method. But we don't want to do that, because you should really only mark things final if they need to be. This is a behavior of Java that I'm actually quite a bit of a fan of, and I wish C# would be virtual by default, but it isn't. Anyway, so that's an interesting note there. The equivalent syntax in C# would be, or the equivalent keyword in C# would be sealed instead of final. And then finally, the last interesting bit of differences with C# and Java, or with other languages, is that Java uses the keyword super whenever referring to the base class. It does not use base for the base class, it uses super. In fact, in Java lingo, it really is superclasses, and for the purposes of this training series, I should get used to saying the word superclass instead of base class. But I think base class sounds better, but of course, I'm probably very biased. Anyway, so super calls through into the base class, and we must do that on pretty much every method that we override that comes from Android. We always need to call back into it. So what is this saved state thing here? Well, we'll be seeing more examples of how to use that later, but the saved state, what that allows us to do is when this activity is destroyed for any reason, we have an opportunity to save our state, to save our little our local variables and whatever else we need into what's called a bundle. And then the Android operating system keeps that bundle around for as long as it needs to, in case our activity is to be recreated for whatever purpose. And then, if it is recreated, it gets passed into the onCreate method so that we can reinflate all of our local variables. So, the saved state will otherwise be null if it is not a if this activity is being created for the first time. Anyway, we could certainly do this. We could leave this as it is and run it, but of course it won't work because we haven't added the activity to our Android manifest. So let's go ahead and do that. Up here in manifests, I'm going to open up Android manifest.xml, and under my application node, which is under the manifest node, I'm going to say activity. And for Android name, so what I did here is all I did was open up a brace, type in AC and hit enter. And you'll notice it auto-completed all of that for me, which is nice. And it also will give me a list of all my activities, which is also very nice. So all I have to do is hit enter, and now I have main activity. So then I'm going to close that tag and then hit enter, because there's a couple other things we have to do. So we have our activity, but we need to tell the Android operating system about it a little bit more than just saying we have this main activity. We effectively are going to give this activity a little star, a special signature that tells the Android operating system that we want this activity to be launched when we press the launcher link in our launcher. So to do that, we'll use what's called an intent filter. The intent filter is responsible for describing to the Android operating system under what circumstances should this activity be invoked. So there's a couple other interesting things we can do with intent filters for things like broadcast receivers, but for now, really the only way in which our application is ever going to be launched is by the Android operating system. Really the only activity that the Android operating system needs to ever instantiate for us from outside the application is going to be the activity that's launched when we press the icon. So how do we specify that? Well, the first thing we need to do is I'm going to go ahead and give this an action, and I'm going to give it an Android name of android.intent.action.main. Then I'm going to give it a category with an Android name of launcher. Now in this case, what I can do is I can just hold down caps and start typing in launcher. Notice how the autocomplete doesn't care that what I want doesn't start with what I've started typing. It also searches in the middle of the string. So I can just hit enter here, and we can do that. So what we're saying here is whenever the action main within the category launcher happens to our app, we want the main activity to be invoked. Okay, so we've now told Android about our activity, or at least our main activity. So let's go ahead and hit run. Now it's not going to ask me for what device I want to use when running, because I've said to not display that ever again, or to use the same device every time. But it might ask you guys. In that case, go ahead and select your Genymotion device, or your physical device, or your Android emulator. And what you get is this. So a couple of interesting things. Our activity launched, and everything's working, but obviously nothing's happening, except for this thing up here, this interesting views part 1. That is the action bar. That is a piece of functionality that we get because we're using app compat, and also because we're using the action bar activity. We'll have a video dedicated to action bars, but so I just want to make sure you guys aren't going crazy like, oh, where did this thing come from? We haven't actually did any views of anything. Well, that's because it came through the theme that we're using and the actual the particular activity base type that we're using. But anyway, that's not all that exciting. So let's go ahead and make it a little bit more exciting. What I'm going to do here is I'm going to go over into the resources folder. Now inside the resources folder, what I want to do is I want to create a layout XML file to describe the user interface for my main activity. So on resources, I'm going to right click, select new, and I'm going to say Android resource file and click that. And then we get a bunch of this, we get this really cool dialog. This dialog is actually really cool. It's not scary at all. So the first thing it wants us to do is it wants us to type in the file name. Now in this case, it's going to be activity _ main, which is basically how I like naming my layouts. So the type of thing it's going to be used for, followed by the name of the thing that's going to be used for. Now, almost all of our layout files are going to be tightly coupled to a particular class in Android, so it's okay coupling the name of the layout to the name of your activity. In fact, it's encouraged because it really makes finding your activity a whole lot easier. Anyway, on resource type, I'm going to select layout. Then it's going to ask me what the root element should be. We're going to keep this with linear layout because linear layout is what we're going to be talking about shortly. Then it asks me what source set that I wanted in. So this will be, like, for example, our build types and our product flavors. So if you had multiple product flavors, we would have that option here of which source set we want to put it in. In this case, we want main. We want it to be on every source set in every build. And then it wants our directory name, which is going to be layout, obviously. Then it has this cool thing right here. This cool thing is a really easy way to go ahead and add qualifiers. Like, for example, if you wanted this layout to only be used if the orientation was landscape, we could click on orientation, we could slide it over, and then we can change this to landscape. And that would mean that this file name or this layout is only going to be used in landscape mode. Or we can go here and on density, and we can say only on landscape for high density screens. Now, what's going to happen with these qualifiers is that they're just going to be appended to the directory name. Just like how we saw before with our different directories of drawables, where you have mdpi, hdpi, xhdpi, those are all qualifiers. And this is just a little GUI that allows us to specify qualifiers very easily within the wizard. But we're not going to be using these qualifiers. Instead, we're going to be creating this as basically a base layout file that's going to be used. So let's go ahead and hit OK. And we get our screen. So this is the designer of Android Studio for layouts. And it's not particularly exciting. It actually works, which is surprising because a lot of... I remember the first time I tried to use this designer years ago. They've made a lot of progress with it. And it's actually not terrible. It's nice to sometimes just sit here and drag out some of these widgets and play with them and see how they respond to different things. But in general, I don't use this designer. I find it significantly faster to work with this in code, in XML, and not in the designer. So to do that, we switch over to the text view, which you see here at the bottom left. Now, fortunately with the text view, we still get our preview, which will show our device, or the current device we have selected, and how it's going to look on that device. Okay, so I'm going to go ahead and bring these out onto their own lines. So here we have a linear layout. We have our XML namespace specified. We have our required elements, layout width and layout height, to match parent, meaning this linear layout is going to expand to the extents of the parent view, which is a view we have no control over. And then we have our orientation, which is set to vertical. Now, the orientation in a linear layout specifies which orientation the things are going to be stacked. So, for example, if I come down here, what I'm going to do is I'm going to open up a tag and type in text view and hit enter. Then on layout width, I'm going to say wrap content, layout height, wrap content, text equals hello. Then I'm going to create a new text view with the layout width of wrap content, layout height of wrap content, and text of world. Now, if we come over here in the preview, we'll see that they're being stacked on top of each other because they exist within the linear layout. So the linear layout is describing how the child elements are positioned. So what we can do here is, instead of vertical, we could also do horizontal. And what that would do is that would make the linear layout lay our things out horizontally. So we have hello and then world. Not terribly interesting. There's really only one more interesting thing about linear layouts, and that is weight. Layout weight is how we describe how these elements should be positioned relative to each other, or specifically how much size, how much spacing should be prioritized to one element or the other. So we can use layout weight, for example, to make these text boxes share equal amounts of width inside of our linear layout, or to have one text box have 3/4 of the width and the other text box have 1. So the layout weight is kind of an annoying sort of thing to deal with because it's a little bit of mental gymnastics to understand it. But basically, it's a ratio within itself. So the layout weight doesn't have any particular values that it cares about. It only cares about the layout weight's relationship between itself and the layout weight of other elements. So what do I mean by that? Well, in here, I'm going to hit enter and introduce a new attribute. I'm going to say layout weight. And then I'm going to go ahead and put in 1. So what's happening here is the width of this hello is taking up as much space as it can, and the world is being shoved off to the side with as little space as it can. Why is that happening? Well, it's because it's relative. It's because this text view, it's because hello has a weight of 1, but the other text view has a layout of unspecified, or 0. So that means that this guy gets everything that he wants up until he's pushing world off to the side of the screen. So how do we fix that? What if we wanted equal amounts? Well, again, the layout weight is a ratio, meaning if we want equal amounts of width, we have to give them both equal layout weights. So down here, I can say layout weight of 1 on my other text view. And now notice how they have equal amounts of distance between, or equal sizes. Let's say I change this layout weight to 10. What does that mean? Well, that means that this is going to get 10 times more space than this guy. But what if I set him to 10? Well, now they're on equal footing again, because again, it's a ratio. It doesn't matter what specific numbers are put into the layout weight, it matters how it relates to the other elements that have a layout weight specified. So you can get relatively interesting results with this. Honestly, the linear layout is the second least flexible layout or view group in the entire system. So it's not that exciting. That's about it. So if, like, for example, let's say that you want this is like a sidebar thing, and you want it to occupy 1/4 of the screen, and this is the content, and you want it to occupy 3/4, then we would create that ratio between each other. I would say 1 over here, and then I would say 4 over here. And now this occupies 1/4 of the screen space, and this occupies 3/4 of the screen space. And that's how layout weights work. All right, well, the last thing I want to go ahead and do in this video is I want to go back into the main activity, and I want to tell it about this activity or this layout. So just because we created a layout and it happens to be named similarly to the activity doesn't mean it gets wired up to the activity itself just yet. We have to tell the activity to do that. So it's very important that we do this after we call super on create. And what we're going to do is we're going to use the set content view method. Now let's look inside the set content view method. We have 3 overloads. The first one is a layout res ID, second one is a view, and the third one is a view and a set of layout parameters. So the first one, what we can do is we can specify the resource that we just created, the layout resource we just created, activity_main. The second one, we can specify a view object that we instantiate ourselves. Because remember, all of these elements inside of this layout file are actually instantiations of a subclass of view that comes from the Android SDK. Even linear layout is a view. They're all views. And so they're all objects. So we have 3 objects that we're dealing with right now. We have 2 objects right here, 2 instantiated text view classes, and then we have a linear layout class that's been instantiated right there, and these 2 have been attached into it as a child, because a linear layout is a special kind of view called a view group. Group implying that it can have multiple views underneath it. So inside of main activity, what we can do is we can give it just a view, and we can give it a view and a layout params. What's a layout params? It's this guy right here. A layout params, we've already been using layout params. Layout parameters, if you're familiar with XAML, are basically attached properties, but a very limited version of that piece of functionality. They're only useful for view groups. You might be coming back here into this XML file, and you might be thinking, well, wait a sec, we specified layout weight, but layout weight isn't really understood by a text view. That would be super inflexible if every single view has to implement the concept of a weight, when the concept of a weight is only appropriate to a linear layout. This is a layout param. The layout param is additional data we tack on to view objects when we pass it into a view group so that the view group can do things differently with it. We'll see examples of a whole lot more of layout parameters when we talk about the relative layout. But anything that starts with layout underscore is a layout param. So that's even our width and our height. So whenever you see layout underscore, that is a layout param that's going to be passed up into the containing view group. The view group is what understands layout params, not the views themselves. Anyway, so that's what a layout param is. Now, you guys have probably already figured out by now, the overload that I want to use is the first one. Int layout res ID. So again, the set content view will basically bring that view to be visible full screen on my current device or my current activity. So how do I access the layout? Well, I do r dot layout dot activity_main. Not that surprising. So we have r, the magical generated class we talked about before, but dot layout, we're specifying a layout resource, and then activity name main, which is the name of our activity, or our layout. So let's go ahead and hit run, and then I'm going to hit run app, and let's look at getting motion here and see what pops up. And as we see, our view indeed does get placed inside of our activity. All right, so yeah, I think that pretty much is what I wanted to do in this video. So I think we'll see you guys in the next one.